43. I want to start right there with a number that really sets the sheer, staggering scale of this disaster. In April 2026, a catastrophic flooding event swept across northern Michigan, and it was so severe that 43 different counties were placed under state-level emergency declarations. We are talking about a massive, region-wide hydrological failure that just completely overwhelmed local infrastructure.
As Governor Gretchen Whitmer put it, the storms, flooding, and tornadoes left an absolutely devastating impact, destroying homes, businesses, and roads. In fact, the state actually had to request a presidential disaster declaration just to unlock the federal assistance required to start rebuilding. But, trying to wrap your head around a disaster of this magnitude from a macro level can be pretty tough. To really grasp what happened, and more importantly, how to defend against it, we need to zoom in.
So welcome to today's Explainer, Surviving the Surge. We're going to take that massive statewide disaster and look at it through the micro-level lens of one specific commercial business, the Pellston Lodge. We are going to look at exactly how the flood systematically choked their operations, and then we'll get into the specific, actionable engineering solutions they need to fight back.
Here's our roadmap for today. We'll cover 1. The 2026 vernal flood. 2. Pellston Lodge underwater. 3. Short-term emergency defenses. 4. Defeating heavy clay soils. And 5. Long-term structural solutions. Let's get right into it.
Section 1. The 2026 vernal flood. Okay, let's dive into the actual climatological causes behind this event.
You see, the 2026 flood wasn't just a really heavy rainstorm. It was literally a meteorological perfect storm. Back in mid-March, a severe winter storm laid down this dense snowpack across Emmett and Sheboygan counties. Then, early April brought this unseasonable heat wave, triggering a rapid snowmelt that completely saturated the region's topsoils. So by the time severe thunderstorms rolled in between April 10th and 21st, dropping another 1 to 3 inches of rain, the ground just couldn't absorb a single drop more. The water had absolutely nowhere to go but up.
Section 2. Pellston Lodge, underwater. This brings us right to the doorstep of our case study. The Pellston Lodge is a 52-room, 2-story motor inn sitting on a flat glacial outwash plain that's just packed with dense clay. And when we look at how regional infrastructure failures cascade down to hit a single business, it's pretty eye-opening. When the airport runways across the street flooded, the lodge lost its primary guest pipeline. The saturated clay soils created immense hydrostatic pressure against their foundation. Down the road, culvert failures washed out parts of M119 and flooded US 31, which physically blocked tourist traffic from reaching them. And meanwhile, that incredibly high water table threatened their ground floor utility drains with sewage backflow and forced them to close their subterranean pool and spa. It's a complete operational chokehold.
24 days. Just think about that for a second. That is a staggering amount of time for the Pellston Regional Airport to be entirely closed to commercial air traffic. For nearly a month, the lodge was financially stranded. And during that whole time, they had to run continuous, round-the-clock pumping just to divert floodwaters into the grassy areas between the airport taxiways.
Section 3. Short-term emergency defenses. So what do you do when the water is actively rising? Let's talk immediate tactics.
This right here is your active emergency playbook, because you simply can't rely on municipal systems when they're overwhelmed. The lodge needs portable 3-inch gasoline-powered trash pumps with rigid discharge hoses to push water entirely off-site, otherwise it's just going to soak right back into the foundation. Forget traditional sandbags, you want water-activated polyurethane barriers and heavy-duty plastic flood wraps for lower doors. Internally, dual-port backflow preventer valves in the sewer lines are absolutely essential to stop municipal sewage from reversing right back into the building. And of course, making sure sump pumps have reliable battery backups is a must. But hey, the fight isn't just physical, there's an administrative battle too. Property owners have to document all their damage with photos and receipts to submit through the county's portal to secure FEMA aid. You also have to lean into local resources like dialing 211 for recovery support. A great example of this is Emmett County extending their flood debris voucher program, giving residents until August 1st, 2026 to dispose of bulk flood debris.
Which brings us to Section 4. Defeating heavy clay soils. Now we need to talk about the true geological villain of our story.
The reason Pellston flooded so severely isn't just the rain, it's the dense clay soil that completely refuses to drain. If you don't understand this, your landscaping fixes will actually make things worse. It's called the bathtub effect. Here's what happens. You excavate clay and replace just the top 8 to 12 inches with nice loose topsoil. Well, water rushes into that improved zone, hits the solid clay walls surrounding it, and just sits there. You haven't improved drainage at all. You've literally built an underground bathtub against your foundation.
And that brings us to a massive landscaping myth: adding sand to heavy clay to fix drainage. Guys, it does not work. It's all about particle geometry. Clay particles are microscopic. When you mix them with sand, those tiny clay particles perfectly fill the gaps between the larger sand grains. Unless you are removing and replacing massive volumes of soil, mixing sand and clay just creates this dense, concrete-like matrix that makes everything worse.
Section 5. Long-term structural solutions. With an understanding of how treacherous clay can be, let's look at permanent engineering fixes.
The key to long-term defense is using the right tool for the job. A French drain is an underground system. It fights subsurface hydrostatic pressure, pulling water away from your slab. A swale is a shallow, vegetated channel on the surface. It uses the natural slope to safely guide surface runoff away. To protect a commercial lodge on flat clay, you absolutely need both working in tandem. Let's walk through building a clay-optimized French drain, because a standard drain is just going to fail here. Step 1, dig an 18 to 24-inch trench. Step 2, lay a 4 to 6-inch perforated PVC pipe. And this is absolutely crucial, lay it with the holes facing down so water rises into it evenly. Step 3, backfill with 3/4-inch clean, washed stone. Do not use crushed limestone, it releases a dust that'll pack into a solid block. And Step 4, your secret weapon. Ditch the standard pipe sock. Instead, line the entire trench with a heavy, non-woven geotextile fabric, wrapping the stone and pipe together in a burrito style. This keeps the microscopic clay out while letting the water flow freely.
Beyond the drains, you've got to regrade the surrounding earth to drop 6 inches over the first 10 feet, maintaining a 2% slope away from the building. Every piece of critical utility equipment, like HVAC units and electrical panels, needs to be elevated on concrete pads at least 1 foot above the base flood elevation. Finally, for the building itself, you can use temporary dry floodproofing, like watertight panels over doors. But note this well. FEMA guidelines permit dry floodproofing for commercial lobbies, but it is strictly banned for actual guest lodging spaces due to evacuation risks.
So, what does this all mean for us? We've seen how this perfect storm of weather, geology, and infrastructure failure brought a thriving Motor Inn to its knees. By understanding the science of clay soils, deploying those tactical defenses, and investing in specialized engineering like burrito-wrapped French drains, properties can survive the surge. But I really want to leave you with this thought. If a 24-day airport closure and vernal flooding can nearly sink a major commercial lodge, how resilient is the infrastructure protecting your own property in a changing climate? Thanks for joining me on this explainer, and stay prepared out there.